5G, gravity. Gravity is a fundamental force of attraction between two objects with mass. All objects with mass are attracted to one another. The larger the mass, the greater the attraction. This attraction is called gravity. The Earth is the biggest thing on Earth, and everything else is relatively small. So all objects on Earth are attracted to Earth. This is called Earth's gravity. Earth's gravity makes it so that all objects near the surface of Earth fall at a constant rate of acceleration. This is true regardless of the object's shape, size, or mass. This constant rate of acceleration is called gravity and has the symbol g. The value of g is 9.8 meters per second squared downwards, or negative 9.8 meters per second squared. This means that all falling objects near the surface of Earth accelerates at 9.8 meters per second downwards every second of falling. Or, simply, the speed of a falling object will increase by negative 9.8 meters per second for every second that it's falling. Negative 9.8 meters per second per second. This animation shows us. Any object dropped will be traveling at negative 9.8 meters per second if left to fall for 1 second. If left for 2 seconds, the object's velocity will now be negative 19.6 meters per second, which is 2 times negative 9.8 meters per second. After 3 seconds of falling, the object will be traveling at 3 times negative 9.8 meters per second, or negative 29.4 meters per second. For some of you, this makes no sense. We have dropped things in the past, and they do not hit the ground at the same time. This video demonstrates this. So on your left, you have a steel ball. On your right, you have a foam ball. The reason for this is an invisible substance called air. Air is made of atoms and molecules which will slow free-falling objects down when the falling object runs into them. It's called air resistance. Air resistance is a friction-like force that counters the movement of falling objects. The maximum velocity of a falling object depends on the object's shape, size, and mass, but also other factors like wind speed and humidity. Terminal velocity is the maximum velocity an object can fall when variables are considered. In a vacuum where most air particles are sucked out, there is nothing but empty space, so two objects, regardless of the shape or size, will fall at a constant rate of acceleration as there is nothing to bump into. This is an example, the silver ball being steel and the red ball being foam. On Earth, the steel ball will reach greater terminal velocity because it has more mass. The extra mass means that it will be able to push out the air particles that it runs into easier than the foam ball. The steel mass has more inertia. Now, if we take two balls of different shape, size, and material and put them on a vacuum, they will fall at the same rate of acceleration, as there is no particles for them to bump into. This was proven to be true when the US visited the moon and a hammer and a falcon's feather was dropped at the same time.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time.